Today, we are going to discuss about Haloform reaction, Cannizaro reaction, Beckmann rearrangement, and Reformatsky reaction. Haloform reaction. Haloform reaction can be simply termed as a reaction of methyl ketones as well as acetaldehydes with the um, halogen in presence of an alkali to form haloform. And according to the halogen taken under consideration, we can name it as chloroform reaction, iodoform reaction, bromoform reaction, etc. So, acetaldehyde and all ketones in which the carbonyl group um, are oxidized by halogen and alkali. The reaction result in the formation of a haloform and the salt of a carboxylic acid containing one carbon less than the parent carbonyl compound. The reaction is called haloform reaction. Here are the examples of some haloform reaction in which acetaldehyde reacts with chlorine in presence of NaOH to form sodium fumate and chloroform, whereas acetone reacts with bromine in presence of NaOH to form sodium acetate as well as bromoform, and acetophenone on reaction with um, iodine in presence of 4 NaOH to form sodium benzoate and iodoform. Not only methyl ketones, compounds like ethanol, propan-2-ol, which get oxidized when treated with halogen and alkali, to aldehydes or ketones containing CH3CU grouping, gave haloform reaction. Uh, let's take a look at the mechanism of haloform reaction. And the initial step is the methyl group of a methyl ketone is converted to an alpha substituted or alpha methyl group by three subsequent halogenation steps acting on it, and that involves the formation of an intermediate, that is enolate ion, by the deprotonation in alkaline solution. And or this hydroxide ion brings about a conversion of small amount of the methyl ketone into enolate ion. The enolate formed is immediately removed by the halogen by reaction, thereby shifting the equilibrium in the direction of further enolate ion formation. Result is the alpha halogenation of the carbonyl compound. And when excess of base and halogen are used, the monohalogenated methyl ketone itself is converted into enolate ion and further halogenated rapidly. Eventually, the methyl group of the original compound gets triply halogenated. The product is then cleaved by base to yield a carboxylate anion and the haloform. Iodoform test. If iodine and alkali are the reagents used in haloform reaction, haloform formed will be iodoform. When treated with iodine and alkali, it would yield a yellow precipitate of iodoform, that is CHI3, having a characteristic order. Since iodoform is easily recognizable, this reaction is used as a test to detect the presence of the structural feature of CH3CU grouping in a ketone or CH3CHOH grouping in an alcohol. This is called iodoform test. Iodoform reaction. Ethanol reacts with iodine in presence of 2 NaOH give acetaldehyde, and acetaldehyde on reaction with 3 molecules of iodine and 4 molecules of NaOH gives sodium fumate and iodoform. Also, propan-2-ol on reaction with iodine and 2 molecules of NaOH gives acetone, and acetone on reaction with 3 molecules of iodine and 4 molecules of NaOH gives sodium fumate and iodoform. Now let's move on to Cannizaro reaction. It is simply termed as the reaction of carbonyl compounds which doesn't possess any alpha hydrogens on presence of strong base. It undergoes a disproportionation involving hydrogen transfer, and results formed would be one molecule of alcohol as well as one molecule of carboxylic acid. So, aldehydes which do not possess an alpha hydrogen atom undergo self reduction and oxidation, that is disproportionation reaction on treatment with concentrated alkali. In this reaction, one molecule of aldehyde is reduced to corresponding alcohol while other is oxidized to corresponding carboxylate salt. The reaction is called Cannizaro reaction. Example, when formaldehyde treated with concentrated NaOH gives methanol and sodium fumate, and benzaldehyde on treatment with concentrated NaOH yields benzyl alcohol and sodium benzoate. Now let's take a look at the mechanism of Cannizaro reaction. And the key step is the initiation step. The reaction is initiated by a nucleophilic addition of hydroxide anion to the carbonyl group of aldehyde molecule to give anion, and base used is very strong, so this anion will undergo further deprotonation also. That is the nucleophilic addition of hydroxide ion to carbonyl carbon of one aldehyde molecule, followed by hydride ion transfer to another molecule of aldehyde. So here is the formation of benzyl alcohol and benzoate ion from benzaldehyde. Cross-Cannizaro reaction. It is possible to plan Cannizaro reaction between two different aldehydes which do not contain alpha hydrogen atoms, in which case is called cross-Cannizaro reaction. That is, two different aldehydes such as benzaldehyde reacts with formaldehyde in presence of NaOH gives sodium fumate and benzyl alcohol. It must be noted that in this reaction, more easily oxidizable formaldehyde is oxidized while benzaldehyde is reduced. Also, para-nitrobenzaldehyde on reaction with formaldehyde in presence of NaOH gives sodium fumate and para-nitrobenzyl alcohol. So let's take a look at Beckmann rearrangement. And Beckmann rearrangement is simply termed as a rearrangement of oximes under the influence of acidic reagents to yield N-substituted amide. So oximes of carbonyl compounds such as aldoximes and ketoximes, these are obtained by the reaction of aldehydes and ketones with hydroxylamine. And these oximes of carbonyl compounds are treated with acidic reagents like concentrated H2SO4, PCl5 or tosyl chloride rearranged to form N-substituted amides. And here we can see the rearrangement of oxime in presence of H2SO4 to form N-substituted amide, that is a benzophenone oxime rearranged to form benzanilide. And let's take a look at the mechanism of Beckmann rearrangement. And mechanism, the oximes on treating with acid catalyst, its protonation of hydroxyl groups of oxime take place. The initial step is the protonation of the hydroxyl groups of amines, and as a result it turns into a better leaving group. And that exact time in which the water departs from nitrogen, and R group with the electron pairs migrate to N, and resulting cationic species will react with H2O to form aminol, and aminol undergo tautomerism to give N-substituted amides. And one thing to be noted in Beckmann rearrangement is OH group in oximes are migrated by Andy group. And applications of Beckmann rearrangement: manufacture of polyamide fiber, nylon 6. Caprolactam, the monomer from which nylon 6 is synthesized, is presented from cyclohexane. And the synthesis of caprolactam: cyclohexane is treated with hydroxylamine to form cyclohexane oxime, and cyclohexane oxime treated with concentrated H2SO4 or polyphosphoric acid to get caprolactam. And conversion of oxime to paracetamol by an acid catalyzed Beckmann rearrangement using CF3COOH SOCl2 and amber list 15, that is an ion exchange resin. Reformatsky reaction. Reformatsky reaction consists of treating an alpha bromoester with a carbonyl compound in presence of zinc in other solution. Subsequent acidic hydrolysis yield a beta hydroxy ester. The mechanism is believed to involve the formation of an intermediate organizing compound of the alpha bromoester, which undergoes addition at the carbonyl group. A few crystals of iodine catalyzes the reaction by means of activating zinc. Ethyl bromoacetate is treated with acetaldehyde in presence of zinc in other solution and system is then subjected to hydrolysis. Ethyl beta hydroxybutyrate is obtained. Ethyl bromoacetate on treatment with acetone in presence of zinc in other solution and system then subjected to acidic hydrolysis. Ethyl beta hydroisovalerate, that is ethyl 3 hydroxy methyl butanate, is obtained. And mechanism involved in Reformatsky reaction is formation of organocin compound from alpha bromoester and zinc is a step 1. This organocin derivative generates a carbanion that gets resonance stabilized. And step 2 is nucleophilic addition of carbanion to carbonyl group of a carbonyl compound followed by acid hydrolysis to beta hydroxy ester. Now, applications important. It is Reformatsky reaction is an important method to prepare alpha beta unsaturated esters and alpha beta unsaturated acid. First, ethyl beta hydroxybutyrate obtained by Reformatsky reaction between ethyl bromoacetate and acetaldehyde in presence of zinc and other solution undergoes easy dehydration to ethyl crotonate, and this upon hydrolysis yields crotonic acid, that is butyroic acid. Ethyl beta hydroxy isovalerate obtained by Reformatsky reaction undergoes easy dehydration to ethyl beta crotonate. This upon hydrolysis yields beta methyl crotonic acid.